Normal distribution. Okay, what type of variable is considered as normally distributed? Normally distributed means the distribution is symmetrical. The distribution is symmetrical. Okay, symmetrical means what? When you say the distribution is symmetrical means they have the same central measure. The mean, the mode, and the median are of the same value. Here is the mean. Here is also the mode. Here is also the median. And the normal distribution will be for continuous variable. So it is a variable that is measurable, and it is a variable that is naturally occurrent. Okay, so I always use that this as an example is God is very fair to everyone, like your IQ, correct? It's a normal distribution. Your score in your any subject is always normally distributed. Most of the people will have that mark. We will have very few very low mark and very few with very high mark. So if you can get your ATA as 99.95, you are the very few of them, correct? You are the top 0.05%. Am I right? That's got 99.95. So we don't have to feel bad if we can't get into that. So we are normal. So as long as we are range around the normal. Yeah. So this is the mean. So the mean is a line of symmetrical. Okay. And it's a continuous variable. So they will have a, so it's normally distributed. These are called the bell shape. Correct? So the chances of it to be very, very small and very, very big is very unlikely to happen. So this is a probability density function for normal distribution. You have the highest point and you have the inflection point also. There are two inflection points here. So before the first inflection point is just concave upward, then concave downward, then concave upward again. So that's why I say the probability of getting very, very big or very, very small is very unlikely. So any variable that is naturally occurrence, like for example, your weight, yeah, our height, all depend on many factors, can be environment, can be genetical, can be the food you take, yeah, can be the exercise that you do, that will determine your weight and your height. Am I right? Okay, like your IQ also, it can be also depend on your genetical factor. One, it can also be depend on the environment that you are exposed to. Yeah, your exposure to it, that can determine your young, when you are young, okay, how much your parents exposed to you, the way your parents talk to you, it can determine your IQ as well. Yeah, so that is called normally distributed. It's bell shape. The three central measures are the same. So may I ask, can you tell me what is the value of this area? So this is a probability density function. So if you look at page 232 of your textbook, the probability density function for a normal distribution is given by this formula. You don't ask me how they get the formula, you ask the statistician, okay? They have this formula. Do you need to know this formula? The answer is no. Okay, I just introduced you with this formula so that you can put it in. So now, what is this? This is the mean. What is this? This is a standard deviation. And how they count it, how they get it, that one when you do a higher level statistic, you will know. So this is not like a binomial distribution, normal distribution. Okay, so if I have a variable x, okay, I tell you it's normally distributed and represent normally distributed. The first number is the mean. Okay, I give you the mean as 8. Okay, and I give you the standard deviation as 2. And usually the number here, they put it standard deviation squared. That is the variance. Okay, so they will tell you. So now, if you key into your calculator, your y1 as this, then you will get the normal distribution curve. 1 over 2 square root of 2 pi e to the power of, okay, I will prefer you to type this as x, negative x minus the mean is 8 square, divide by, look, the standard deviation square is 2 square, correct? So it's equal to 4. So here you type in 2 times 4, that is 8. Can or not? So you put it like that, then you times into your graphic calculator. Negative half x minus mean square over standard deviation square. So this will be equal to negative half x minus 8 square over 2 square. Isn't it 2 square times 2 square is 4, 4 times 2 is 8. That's how I get into this. Okay, please key this into your graphic calculator as your y1. Okay, key in ID. Okay, key in ID. Then you try to sketch the graph. Just go to Zoom standard or Zoom, you select your X from 0 to maybe 20, then you do a Zoom fit. Then you see how the graph go. Is the graph exactly like what I have here? Yes. Yeah, you got that. Yeah. So you got the graph. Yeah. So it's a bell shape. And you see the highest point, isn't it? The X value is the X is 8. Is it? Yeah, it's 8, correct? So the mode is 8, the median is 8, the mean is 8. Okay, can or not? Okay, so now, can I move on? Okay, now, so my X is a normal distribution and mean is equal to 8, standard deviation equal to 2. Okay, the graph that I get will be like that. And here is your 8. Am I right? This is a line of symmetry. Yeah. Okay, so now, if I ask you this question, what is the probability that X will be less than 8? What is the chances that X will be less than 8? What should be the total area bounded by the curve? Is equal to 1. So now, the area bounded by the curve represent the probability, correct? So now I ask you this question. What is the probability of x less than 8? Okay, 0.5. We have the answer. Agree? Why is it 0.5? Because 8 is also the median. 50% of the data will be less than the median. That's why it's 0.5. Yeah. Now, if I want to find the probability of x less than 7.2, what should I do? What should I do? Oh, I put it greater than 0. Okay, what should I do? Yeah, since I got the probability density function, I can integrate. Integrate from 0 to 7.2 y1 dx. Okay, we go back to our this one. This is my probability density function, correct? Your y1 is your probability density function, am I right? It's in your y1 for this case. What is your answer? Definitely less than 0.5, correct? 0.345. Oh, nice number. Okay. So you use FNINT. Am I right? Okay, now, if I ask you to find probability of x between 2 and 14. Okay, can you give me the answer? X between 2 and 14. So same thing, you integrate from 2 to 14. Y1, you just put second enter, change the limit, then can edit. So what do you get? Okay, 0.997. Correct? So if we are quite sure, 100% sure. Okay, now, when you say 2 and 14, can I write this as probability of x less than 8 minus 3 times of 2, 8 plus 3 times of 2. This is your standard deviation. This is your mean. This is your mean. This is your standard deviation. So for any given normal distribution, okay, we are very sure that this is called within 3 standard deviation away from mean. So for any given normal distribution, for whatever standard deviation, whatever mean, we are almost 100% sure that all values of x are within 3 standard deviation away from the mean. So this is a true fact about any normal distribution. So that's why the graph after 3 standard deviation away, almost touching the x-axis. The chances of the value to be 3 standard deviation more than the mean and 3 standard deviation less than the mean is negligible. That is characteristic for normal distribution. Are you clear? Okay. So these are the characteristics of a probability density function of a normal distribution that you have to take notes of. And can you please look at page 234? Okay, look, page 234, correct? So these are the rough judgment of the probability or the area bounded by the curve. If it's 1 standard deviation away, you know that the chances of it to happen is 64.26%. Correct? Are you okay? So this is just a judgment. And exercise 8C, you are going to judge all that using the value given in that. So in our test or in our normal doing, we are not going to use that. So how are we going to find probability if it's given? Or how are we going to, we learn how to sketch the graph first. So I'm going to teach you how to sketch the graph without keying the function into the graphic calculator. So please take note, I'm going to teach you how to sketch the graph. So if X is a normal distribution with a mean of 8 and a standard deviation of 2. Yeah. So now I'm going to sketch the graph. I'm going to prepare the x-axis. I'm going to put the middle line. That is where the mean, the axis of symmetry, that is where the mean. So I will put here 8. So my standard deviation is 2. So I know that my highest point should be 8 plus 2 times the standard deviation, 3 times the standard deviation, correct? So it will be 8 plus 3 times 2, that is 14. So 1 standard deviation, 2 standard deviation, 3 standard deviation. That is, here is 14. So here 8 plus 2, 10. 10 plus 2, 12. Here minus 3 standard deviation. 8 minus 2, 6. 6 minus 2, 4. 4 minus 2, 2. So I know that the chances of the value of X less than 2 is negligible. So I put a mark here. The probability is very unlikely, almost touching 0. Correct? And the chances of X to be more than 14, there is 3 standard deviation more, will be negligible also. Okay? And where is the inflection point? The inflection point is always one standard deviation away from the mean. That is somewhere here, I don't know, and somewhere here. One standard deviation. So this is another true fact. So now, how am I going to know? Okay, so now I mark my highest point first. This is your highest point. So from the highest point, 1/3 down. So this is your inflection point. Okay. Hello? So now, look, from here to here is concave. Up. From here to here is concave down. From here to here is concave up this way. So you put an arrow here, done. So that is how you sketch your graph without the help of a graphic calculator. Got it? So this is a procedure every one of us must follow. If not, you key into the graphic calculator. And you also don't know where is the location of the inflection point. Am I right? So you will get a nice shape. You get me? Okay, what is the total area bounded by this curve? 1 unit, always 1 unit, regardless of their mean or standard deviation. Because this is a probability density function. You get what I mean? Okay, so far so good? Good. Can I? So you know how to sketch the graph. You know what does the area bounded by this graph means, how to get the probability. Now, if I don't key in the function, probability density function, is it possible for me to get the probability of something to happen without keying in the function? The answer is a yes. We are going to learn how to use our GC to get all the probability. Hello? Got it? Okay, let's go. Can I? So now, if I give you X is a normal distribution, okay, with the mean of 8 and a standard deviation of 1.5. Okay, now I want to know the probability of X greater than 9.5. Okay, can you make use of page 234 and get the answer? Can you base on the curve in 234 and get the answer, please? Huh? 34 point? 13%. Okay, you get 13%. How you get 13%? Here is my 8. Here is my 9.5. Am I right? Yeah, so here is 34.13%. So can I say this is 0.5, take away 0.3412? Can I say like that? Yes or no? 0.5 take away 0.3412. 13, sorry. Can I say like that? Everyone, are you okay? 0.5 is the whole thing here. If I don't want, I can take 0.1359 plus 0.0215 plus 0.00133. Whatever at the tail there. Also can. So I will get the answer. Correct? That is based on the graph. Okay, now if I don't want, how am I going to use my GC? So now you please use your GC. Huh? Okay, where should you go? Can someone tell me where should I go for GC? Okay, GC, where to go? Yes. Second, vase. Okay, which one to choose? You have two normal, correct? Should be CDF. It cannot be PDF because for that particular value of probability to, for that particular value of X to happen, the chances is equal to 0, correct? We know that from the previous one. So you select normal CDF. Correct? Please choose normal CDF and key in. Okay, lower is 9.5. Okay, look, when you say greater than, that means from 9.5 onward. There is no upper boundary, correct? The moment there is no upper boundary, the upper, we always put very big, 10 to the power 99. Are you clear? Can you please start doing it? Your calculator, no upper boundary, put 10 to the power 99. Then the mean is equal to 8 and the standard deviation equal to 1.5. And you put enter. I believe you will get the same, almost the same value. Correct? You get 0.6587. Hey, what 6587? I must be crazy. 0.2. 1587. Must go back to standard one. Don't know how to minus. Okay, so now everyone, you know how to get. That's why I said the table on page 234 is just a guideline for you. So you see table for 234, you only can talk about how many standard deviation away. So now, got it? So if I want probability of X less than 7.2. So now this one, you cannot use the graph show in page 234 anymore, correct? 7.2. So now what should I do? Got equal, no equal sign, doesn't matter. So what should I do? I use my GC. So is there a lower boundary? No. So if there is no lower boundary, you always type in negative 10 to the power 99. Negative, negative 10 to the power 99. Lower, negative 10 to the power 99. Upper, 7.2. Mean 8, standard deviation 1.5. Okay, can I have the answer? So I always will record down like that. normal, CDF, negative 10 to the power 99, 7.2, 8, 1.5. Okay, I will write down this to tell the examiner exactly which program I use and how I use it and how I key it in. Okay, what is the answer?
0.297.
297, is it? Okay, so you see? So now you know how to use when it's a normal distribution, continuous variable, you know how to use your calculator to get the probability. Am I right? Okay. So everyone know, in between, you shouldn't have any problem. Okay, now.
In progress.
Correct? Because of the sign less than. So less than K means area to the left of K is 0.645. So therefore, my K is more than 8. Okay, if you cannot, I will draw down the bell shape. Here is 8. So K must be here. So that this area can be 0.645. Clear? Okay? Can or not? Okay, so now, how am I going to find K? Using your graphic calculator. So go to second vase again. You tell me which one to use. You are doing the reverse. Yes, you are supposed to use inverse norm. Inverse norm. Faster, take out your graphic calculator. Second vase. Inverse norm. Okay, what is the first number you're supposed to key in? Area. So you key in 0.645. The next one, mean. The next one, standard deviation, 1.5. The next one, this area, is it to the left of K or to the right of K or center? Left of K. So you select left. Then you put down. So you write down K equal to, what is the value of K? 8.558. So it's approximately 8.56. Okay, so very easy, huh? No need like high school, huh? Go to the table, find again. Am I right? Ha ha, done. This.
Recording progress.
So now can you please tell me which graph, which distribution the graph will be tall and thin? You know the area must be always 1 unit, am I right? So you imagine it like a rectangle. The standard deviation tell you the width. So which one must be tall and thin? Wide. Yes, this is tall and thin. Why? Because the standard deviation is smaller. it has a smaller spread. Correct? Then the other one will be short and fat. But how is the ratio of the height? The ratio of the height depends on the ratio of the standard deviation. Correct? So, standard deviation of X over standard deviation of Y is 2 over 1.5. Am I right? Yep. So it will be, turn it into improper fraction. Can I say is 4 over 3? So which one is taller? Y is taller, correct? So which means that now the height for Y and the height for X, which one is taller? Y is taller, correct? So Y will take 4 parts, X will take 3 parts. The other way around. Am I right? Logic or not? Smaller spread, taller, ma? Okay? Got it? So that is how you judge the height. Okay, so now, when we want to prepare to draw, first of all, we try to have enough space above. Okay, don't be stingy with your space. So your x-axis, your horizontal axis, center, so when we mark, we always mark the greater spread. So you look at X. So X has a bigger standard deviation, correct? So the lower should be eight minus 3 times 2. Am I right? 3 times the standard deviation. So that is 2. And the highest for X will be 8 plus 3 times 2. That is 14. We get a bigger spread first. If not afterward, if you take a shorter spread after, it's not enough for a bigger spread. So 0 plus 8 10 12 14 6 4 2. Got it? After we get that, then only we get the standard deviation of Y. Okay, for standard deviation of Y, we know the standard deviation is 1.5, correct? So 8 plus 1.5 is 9.5. Here is your 9, here is your 9.5. Am I right? $11. So the next mark is here. Am I right? Plus another 1.5. 12.5. 12 is here. 13 is here. 12.5 is here. See or not? Hello? Got it? So now the other way around. 8 minus 1.5 is 6.5 is here. I use different color so that you can know. Okay, 6.5 minus 1.5 is 5. So it's here. 5 minus 1.5 is 3.5. 3 is here, 3.5 is here. Okay. So done, ready? So I have prepared my horizontal axis. Now I want to do my vertical axis. So I know that y will take 4 parts. So I will divide into 4 parts. Okay. You see or not? Everything I do step by step. So y is blue color, 4 parts. Highest point of y is here. 3 standard deviation of y is here. Am I right? 1 standard deviation is here. So it's around 1/3 down. So it's around here. It's around 1/3 down, around there, Kennedy. See or not? So I got all the important points. So now I can draw the graph for y. Are you okay? So now I can draw the graph for y. A bit steeper, go up. Concave. A bit steeper, go down. Put the arrow here. You can draw a very nice curve. Got it? Now, can I proceed with the x? Okay, now I want to proceed with the x. X take 3 parts, am I right? So 3 parts. Inflection, okay. 3 standard deviation away, so the graph will fade away here. From here, go down about 1/3. 1 standard deviation away. In this case, my graph happened to be touching, it may not. Okay, you got all the point? Now you can draw the graph. So this is for x, and this is for y. See or not? Okay, got it? So in the exam, I can ask you to sketch. So the 3 points, 3 important points: ending point, inflection point, highest point. Mark first, then only draw. Okay? So now, I'm going to ask certain questions based on this graph without using the graphic calculator to find the probability. Okay? Here is your 5, huh? Okay, I ask you. Probability of y less than 5. Fill in the blank. Probability of x less than 5, which is bigger? Which is bigger? Y less than 5 or X less than 5?
Y bigger than
Probability of Y less than 5, is it bigger or less than probability of X less than 5? You know, area bounded by the curve of probability density function represent the probability, correct? So which one? The blue is here. The black, that is X, is here. The chances of X less than 5 is higher or Y less than 5 is higher? X, yes, you are right. So the sign should be like that. Because X has a greater spread. You look at the area for the black is greater than the area for the blue. So when I ask you to base on the graph and look, you have to look at the graph. You have to look at the area. Am I right? But if I now put it the other way around, probability of Y greater than 5, which is greater? Probability of X greater than 5. So now this one should be greater, correct? Because the blue area will be bigger. That one you have to go and shade it by yourself. Am I right? So you have to look at the sign here. You cannot just base on that one. Are you clear? So you have to look at the graph, whether to the left or to the right. You see? That is the purpose of sometimes we ask you to sketch the graph. We want you to base on the graph, not just every time use a calculator. If the calculator didn't give you the value, you can't analyze. You get me? Okay. So tomorrow I will talk about the Z-score. Okay, I have a